ever pondered what the future of transportation might look like and how hydrogen fuel cell vehicles fit into that picture? Well, the future of transportation is a hot topic, and it's not just about flying cars or teleportation. It's about sustainability, efficiency, and most importantly, reducing our carbon footprint. This is where hydrogen fuel cell vehicles, or FCEVs, come into play. These vehicles represent a significant leap in automotive technology, promising zero local emissions and a respectable driving range. Imagine roads filled with vehicles that emit nothing but water vapor. Sounds wonderful, doesn't it? But let's not get ahead of ourselves. Although FCEVs hold immense potential, there are some crucial considerations to keep in mind. Hydrogen, while abundant and clean burning, is notoriously difficult to handle. It has a low energy density per unit volume and poses certain safety concerns. Moreover, the environmental benefits of hydrogen vehicles greatly depend on how the hydrogen is produced. If it's derived from non-renewable sources, it can still contribute to pollution and carbon emissions. Then there's the comparison with battery electric vehicles, or BEVs. In many aspects, hydrogen fuel cells have few advantages over batteries and face several critical disadvantages. The cost of hydrogen fuel cell technology, infrastructure development, and hydrogen production can be relatively high. Also, the lack of a widespread hydrogen refueling infrastructure is a significant barrier to the adoption of FCEVs. But despite these challenges, the future of hydrogen and transportation isn't necessarily bleak. Ongoing research and development efforts in the field aim to address these hurdles and make hydrogen a more viable and sustainable option for the future. So, buckle up as we embark on this journey through the world of future transportation, where hydrogen fuel cells might just play a starring role. Now that we've set the stage, let's delve into the fascinating world of hydrogen fuel cell vehicles. To appreciate the potential of these vehicles, you first need to grasp how they work. So let's dive into the fascinating world of hydrogen fuel cell vehicles. Imagine a place where hydrogen and oxygen come together in a dance of chemistry, producing electricity, heat, and water. This is what happens in a hydrogen fuel cell vehicle. At the heart of this vehicle is a fuel cell stack. Picture it like a futuristic battery, but instead of storing energy, it creates it. This fuel cell stack is fed with compressed hydrogen gas. The gas doesn't come from some wild science fiction source, but simple everyday water. By using electricity, water is split into its basic components, hydrogen and oxygen. The hydrogen is then stored in high-pressure tanks within the vehicle, ready to be used when you turn the key. When you're ready to drive, this compressed hydrogen is fed into the fuel cell stack. Here it meets with its old friend, oxygen, which is drawn in from the surrounding air. Now here's where the magic happens. In the fuel cell stack, hydrogen and oxygen engage in a chemical reaction. This isn't some dramatic, explosive reaction, but a controlled one, carefully managed by a catalyst within the fuel cell. The result of this reaction is electricity, which powers the electric motors to drive the vehicle. But that's not all. This reaction also produces heat, which can be used to warm the vehicle in colder climates, and water, which is expelled as harmless water vapor. Yes, you heard it right. The only emission from a hydrogen fuel cell vehicle is water vapor. That's it. No harmful pollutants, no greenhouse gases, just plain old water. Understanding how these vehicles operate brings us one step closer to appreciating their potential benefits and challenges. So now that we've seen how hydrogen fuel cell vehicles work, let's delve into the advantages that make this technology so promising, as well as the challenges it faces. With the basics covered, we can now explore the advantages these vehicles offer. Hydrogen fuel cell vehicles, or FCEVs, bring a unique set of benefits to the table, and they're not just about being futuristic and cool. Let's start with the most compelling advantage: zero local emissions. FCEVs produce no harmful emissions at the point of use. The only byproduct of the chemical reaction between hydrogen and oxygen that powers these vehicles is water vapor. This means that driving an FCEV contributes to cleaner, healthier air quality in our cities and towns. Just imagine a world where car exhaust is a thing of the past, replaced by harmless water vapor. Next, let's talk about the driving range. One of the biggest concerns for electric vehicle drivers is range anxiety, the fear of running out of power before reaching a charging station. hydrogen fuel cell vehicles can travel 300 to 400 miles before needing a refuel. This range is comparable to many conventional gasoline-powered vehicles and superior to most battery electric vehicles or BEVs on the market today. Moreover, refueling a hydrogen car can take as little as 3 to 5 minutes, similar to traditional petrol or diesel vehicles. This quick refueling time, combined with a decent driving range, can make long-distance travel more convenient compared to BEVs, which often require longer charging times. And let's not forget the potential for renewable hydrogen production. While it's true that today's hydrogen is mostly produced from natural gas, a fossil fuel, the future holds promise for green hydrogen produced using renewable energy. This could make hydrogen fuel cell vehicles not just zero emission, but truly sustainable. These advantages paint a promising picture. But it's not all smooth sailing for hydrogen fuel cell vehicles. The path to a hydrogen-powered future does have its obstacles. Let's start with handling difficulties. Hydrogen as a fuel source can be quite a handful. It has a low energy density per unit volume, which means you need a lot of it to generate substantial power. Plus, it presents safety concerns because it's highly combustible and needs to be stored under high pressure. Next up is the environmental impact of hydrogen production. The greenness of hydrogen vehicles hinges on how the hydrogen itself is produced. If it's made using non-renewable sources like natural gas, the process can contribute to pollution and carbon emissions, negating some of the environmental benefits. Now let's talk about cost. Hydrogen fuel cell technology, infrastructure development, and hydrogen production can be quite expensive. The high cost of fuel cells is primarily due to the use of platinum as a catalyst to accelerate the chemical reactions. Plus, building a whole new infrastructure for hydrogen refueling doesn't come cheap. Speaking of infrastructure, that's another significant barrier. Currently, there's a lack of a widespread hydrogen refueling infrastructure. This means that even if you have a hydrogen car, finding a place to refuel it can be a real challenge. Lastly, we have delivery inefficiencies. The process of producing, transporting, and distributing hydrogen to customers is energy intensive. This in turn makes it less efficient than directly charging a battery electric vehicle from the grid. In comparison to battery electric vehicles, hydrogen fuel cells find themselves at a disadvantage. While they do offer some benefits, they also face several deal-breaking challenges. For example, a battery electric vehicle can be charged at home, but a hydrogen car requires a trip to a refueling station, which may not even be available in many areas. These challenges present significant hurdles to the widespread adoption of hydrogen fuel cell vehicles. But it's worth noting that ongoing research and development are aimed at addressing these issues, making hydrogen a more viable and sustainable option for the future. Despite these challenges, the story of hydrogen fuel cell vehicles is far from over. The world of science and technology never rests, and neither do the dedicated researchers and engineers who are tirelessly working to address the shortcomings of hydrogen fuel cell vehicles. The focus of their efforts is wide-ranging, from refining the process of hydrogen production to make it more environmentally friendly and less energy-intensive, to developing more efficient methods of storing and delivering the hydrogen fuel. These pioneers are also working on improving the fuel cell technology itself to make it more robust, efficient, and crucially more affordable. And it's not just about the vehicles. A lot of work is also being put into developing the necessary infrastructure to support a hydrogen-powered future. This includes everything from building more hydrogen refueling stations to creating new supply chains and distribution networks. What's more, researchers are also exploring other potential applications of hydrogen fuel cell technology beyond cars. Think buses, trains, and even ships powered by hydrogen. Imagine a world where the heavy-duty transportation sector, which is currently a significant contributor to global carbon emissions, could be transformed into a clean, green, hydrogen-powered industry. The potential of hydrogen as a sustainable option for the future is immense. Yes, there are challenges, yes, there are hurdles to overcome, but with continued research and development, and with the collective will of governments, industry, and consumers, these challenges can be met. So, let's not write off hydrogen just yet. It may not be the perfect solution right now, but with time, with innovation, and with determination, it could play a significant role in our transition to a cleaner, greener future. The road to a hydrogen-powered future may be full of twists and turns, but the journey is just beginning. Thank you for joining us on this exploration of hydrogen fuel cell vehicles. Remember to stay curious and keep exploring.